Imagine assigning a Jira ticket to an invisible assistant, and before your morning coffee finishes brewing, the code is written, tested, and waiting for review. This is a highly achievable reality. By connecting standard project management tools to modern agentic LLM workflows, we can build a fully automated feature development pipeline. To set this up, you only need 4 things: admin access to your Jira workspace, a target code repository, an LLM API key, and a local backend environment to run tests. This flowchart maps out our core blueprint. We will build 4 connected pillars: a trigger to listen for tasks, a backend orchestrator to manage the flow, an AI agent brain to draft the code, and a gateway to push the final product to GitHub. By connecting these 4 pillars, we eliminate the friction of boilerplate setup and manual context switching. You reclaim hours of focused technical work every single week. Looking at the first stage of our pipeline, the trigger, the process begins the moment a user transitions a ticket to the active column inside Jira. Inside your Jira system settings, we create a brand new webhook. We configure it to fire on an issue update and apply a strict JQL filter so it only triggers when tickets move to in progress. Jira sends out a JSON payload. The summary and description fields isolated here become the exact prompt context our AI uses to understand the task. Because we rely on Jira to push this webhook outward rather than constantly polling the API, the orchestrator reacts instantly to your instructions while completely avoiding arbitrary API rate limits. Moving to the second stage of the pipeline, our orchestrator catches that webhook and initializes a large language model inside a temporary local workspace. If we pass the Jira description to a standard text prompt, the AI guesses your architecture and likely suggests code that doesn't fit your project's specific dependencies. To fix this, we write a script that binds specific utility tools to the agent. We give it a file search tool to find relevant components, a read tool to view existing files, and a write tool to modify them. We then construct a system prompt instructing the agent to actively analyze the existing architecture and adopt your established design patterns before it drafts any new logic. By granting the AI these specific tools, it moves from guessing based on general knowledge to acting on the specific constraints of your files. This grounded context reduces the frequency of the model proposing functions or variables that don't actually exist in your project. Once the agent finishes drafting the feature, we arrive at the third stage of our pipeline: verification inside the local test environment. Letting an autonomous coding agent loose in your repository without strict safety guardrails is dangerous. It can quickly overwrite critical files and break your build. Our orchestrator prevents this by executing the project's test suite. If it fails, the backend captures the terminal error. This triggers a self-healing loop. The orchestrator feeds the error back to the agent for a fix. We hard-code a limit of 3 retries. Running this strict verification loop ensures that whatever code eventually clears the process is guaranteed to be syntactically valid and mathematically sound. With the test passing, we move to the final stage of the pipeline, the gateway, where the verified local code interacts with the GitHub API. The orchestrator executes a standard Git sequence. It checks out a new feature branch, commits the verified changes with a clean message, and pushes that branch to your remote repository. Here we enforce the golden rule of AI automation. An AI agent must never merge code directly into the main production branch. Instead, the orchestrator opens a pull request. The automated description maps out the files changed and includes a direct hyperlink back to the Jira ticket. By restricting the AI to the role of a capable assistant who prepares pull requests, you guarantee that all complex business logic remains under absolute human oversight. This automated pipeline will not replace a seasoned software engineer. Deep system architecture and nuanced business rules still demand human ingenuity, but routine feature requests and tedious boilerplate generation are problems this system solves perfectly. The result is a workflow that converts a Jira ticket into a tested, pushed, and documented branch. This maps human requirements to code execution using a repeatable, programmatic bridge. I've included a link to a boilerplate repository in the description so you can clone this setup. Drop a comment below and let me know, what part of your development loop do you plan to automate next? When you automate the tedious mechanics of code implementation, you finally free up your mental energy to focus on actual problem solving.